So this is the natural log of x plus 1, and you can see that there's an inside function right there. It's not just the natural log of x, so that's going to require the chain rule. But I also have division happening right here. So I have a fraction bar, so that's the natural log of x plus 1 divided by x squared. So this is the quotient rule, as well as the chain rule. So the quotient rule is bat tab over the bottom squared. So it's bottom times derivative of the top. So I'm going to write m prime of x equals the bottom, you just copy the bottom, times the derivative of the top. So right away we have to go into the chain rule. The natural log of u, the derivative of the natural log of u is u prime over u. So my u is x plus 1. My u prime is the derivative of that, which is just 1. So it's bottom times derivative of the top minus the top, which is just the natural log of x plus 1. You just copy it, times the derivative of the bottom, which is 2x, over the bottom squared. So I have x squared squared. That would be x to the fourth. So there are definitely some things that I can cancel out right now. I'm going to clean this up a little bit, and there's a different order. You could do these things in so many different orders, but I'm just going to combine it a little bit here. So one thing that I can see, and I'm going to change this to an x to the fourth, is that I have an x in every single term. So I have x squared here, a 2x here, and then an x to the fourth here. So I can cancel one of those x's out. So this will no longer be x squared. This x would cancel, and this becomes x to the third. So that's one thing you could do. You could do it now, or you could do it later. I'm going to do it now. So when I do this, I'm going to write down that this is x over x plus 1, because this is like an x plus 1, and I'm just combining these two terms. Then I'm going to bring the 2 in front of the natural log, so minus 2 natural log of x plus 1. And then I'm going to divide all of that by x cubed. So you could declare yourself done right there, and I'm okay with that. If you want to practice really cleaning these up, I have a fraction inside of a fraction right here, and that's not so much fun. So the way we're going to clean those up quickly is you're just going to multiply by a very clever form of 1. And the way you find that 1 is you look in the denominator of any fraction you have in this problem, like the fractions within a fraction. So not that x cubed, but the x plus 1. And I'm going to multiply by x plus 1 over x plus 1. So what's going to happen is that we have a big distribution problem in the numerator. So I'm going to write m prime of x equals, and this x plus 1 over here will cancel with this one here, and I'm just left with an x. But it is distribution, so I'm going to bring this in. So minus 2 times x plus 1 times the natural log of x plus 1. And then in my denominator, I have x cubed times x plus 1. So you can still see that there are other things I can do, but I've at least gotten rid of the fraction within a fraction. So things you could do if you chose, I could distribute the 2, and it would be minus 2x plus 2, and that would have to be in parentheses times the natural log of x plus 1. And then, of course, I could distribute the x cubed in my denominator, but you don't want to do that. You'll set these equal to 0 and factor to solve. So you're actually fine the way it is right now. And I am okay with you stopping right here until we start using these. And to be honest, none of them will look this bad when you actually start using these. So you would be done with the red box.